All right, here we are talking a basic physics problem, velocity versus speed. We're looking at a swimmer, and what I didn't put on this problem is the time it takes the swimmer to do this. So I'm going to have to pencil that in there. I can't believe I forgot to do that. But the swimmer's speed, the time it took him to do this is 1 minute and 45 seconds. That was on the board, but I forgot to type it in there. So that's its time. What we're going to do is take the exact same event here and look at it in terms of speed and in terms of velocity so that you can see the difference. The equation for speed is simply distance over time, and for velocity is displacement, or delta x, over time. And I want to show you the differences. So we'll do this first one in kind of orange color. This is 50 meters. So this represents like a helicopter view of the pool looking from above down. So it's 50 meters in this direction here, 50 meters. If you're swimming 2.5 laps, you go down here and back, and then down, and then back, and then back down. And that would be a total distance of basically 2.5 times 50, which is 250. Okay, that would be down and back, and then down again. So you would wind up down here when he's all done. 2.5 laps. So distance, if speed equals distance over time, then 2.5 laps would be 250 meters over the number of seconds. Now, you don't want to put 1.45 or anything crazy like that. A minute is, of course, 60 seconds. Plus the 45 extra seconds would be 105 seconds. And if we take 250, which I'm going to do on my calculator here, and divide it by 105 seconds, I will get 2.38 meters per second. So this would be a swimmer swimming a realistic speed of about 6.5 feet a second. I'm sure there are swimmers that could do that. Even though I just made this time up, I'm sure the world record time is probably faster than that. Now, how does that... So that would be the answer to the average speed. What about the velocity, though? Well, if you start here, and then you go down here, come back, go back down... So I'll erase it. But you go here, 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 that would be 2 laps, and then you wind up here on your 3rd lap. That would be a total displacement of from here to here, which is just 50 meters. So unfortunately, the swimmer's not going to get credit for all of his efforts here. So our velocity, which is delta x over t, which the total initial position and the final position subtracted is just 50 meters total. This would be 50 meters divided by the same time period, which is 105 seconds. 105 seconds. So if we now take 50 and divide it by 105, we're going to get something like 0.48 meters per second, which is a speed that I could probably swim, or a velocity. So there you go. This is a great little example that illustrates the difference of speed versus velocity. And have a good one.